What is Area 51 actually used for? Well, I could tell you, but then I'd have to kill you. No, just kidding. I'm astrobiologist David Grinspoon from NASA. Let's answer your questions from the internet. This is Alien Support. Disgruntled Hermit asks, what's the most interesting exoplanet you've read about? If I had to pick a favorite that we found so far, it would be the planets in the TRAPPIST-1 system. There are 7 planets in the system that we've identified so far, and probably about 3 of them are potentially habitable. And by the way, the TRAPPIST system is only 40 light years away, which if you consider that our galaxy is 100,000 light years across, that's relatively close. I have a sort of chart here, and you can see the habitable zone of the TRAPPIST system with several potential planets in it, compared to the habitable zone of our solar system on the bottom, which has Earth and then, sort of possibly Venus and Mars on the edges of habitability. And by the way, the TRAPPIST system here, it's a cooler star than our sun. It's a red dwarf, and so the planets are clustered very close. But imagine what it would be like for life evolving on a system with multiple habitable planets nearby one another. Meteorites occasionally get blasted off of one planet and land on another. We have pieces of Mars here on Earth. So if you have a habitable planet with life and another planet that could be habitable, you could imagine life spreading easily. Jabalanki asks, are aliens real? Well, my thought is that aliens are real. There are probably something like 30 billion habitable planets in our own galaxy. And so even if a small fraction of those have an origin of life, there's lots of life in our galaxy. And the more we study Earth and its origins, we haven't found anything that's sort of magical or so special about Earth that those things shouldn't be happening elsewhere. So if you're asking me, do I think aliens are real? Yes. If you're asking me, do I know scientifically? I'll say, not yet, but we're on the road to find out. Here's a question from Quora. How accurate is Arrival scientifically? I really like the movie Arrival. I'm watching this scene here with this astrobiologist lost in wonder and awe and a little bit of terror encountering this alien. We talk about convergent evolution, that evolution on other worlds would find some of the same solutions. So the idea that they have something that's like fingers for grasping, that makes sense. The idea that they would have this kind of symmetry, just like we have bilateral symmetry. They look vaguely squid-like, vaguely octopi-like. I wouldn't be surprised if we saw complex aliens if they looked somewhat familiar, but not exactly like any organism we had seen before, because again, they'll be responding to the same overall kinds of evolutionary forces. And then you have the other factor where she's trying to communicate, and this alien is doing this weird kind of circular writing, and it turns out that they are trying to communicate with us, and they're as equally puzzled by us. That makes sense, because I think there's this whole idea, something called incommensurability, that it might really be hard to communicate, because they might have very different kinds of cognition, very different notions of reality and time. So I find this alien very convincing. Utopia Circle asks, how exoplanets are discovered. You can't directly observe the planet because they're too dim and too far away, but you can notice what the planet is doing to the star. So as a planet orbits a star, because of the gravitational pull of that planet, the star actually wobbles a little bit. So that star is wobbling because there's a planet around it, even though you can't see the planet. So some of the time, the star is coming towards your telescope, and some of the time, the star is coming away from your telescope. We call that a Doppler shift. When it's coming towards you, the frequency shifts to a higher frequency. Blue, when it's coming away from you, it shifts to a lower frequency, red. And so our instruments got good enough to detect that slight change, that rhythmic change from blue to red to blue to red. It's a very, very tiny shift in wavelength. And that was the first sign. And then later on, there was a new technique. That's called the transit method. When a planet passes directly in between you and the star, you can notice that little bit of dimming of starlight. It's very tiny because planets are small compared to the stars. But if you have a very sensitive measurement of the light of that star over time, when a planet passes just in front of it, the star will dim a little bit. And so if you watch the light curve over time of that star, it'll wobble up and down and up and down and up and down. So you're not so much seeing the planet as noticing that the planet is blocking the star a little bit, causing it to periodically dim. It only works when the geometry's right. If it's a little bit above or a little bit below the direct line between your telescope and that star, you'll miss it. So only about 5% of stars have planets oriented in the right plane, the right direction to use that transit method. But when things are lined up right, it's very sensitive. So that has allowed us now, especially with space telescopes, like there was an instrument called Kepler that was designed to use the transit method to find lots of exoplanets. And that was really what revealed to us that most stars in the universe have planets. Sohat Virgo asks, where do astrobiologists work? How hard is it to get a job in astrobiology? So astrobiologists work a lot at universities. Some of them work in government labs. Some of us build spacecraft and send them out to observe other planets. Some of us do field work and study exotic locations, go on expeditions where there's extreme life to understand the limits of life and look for some of the earliest signs of life. This is a rock called a stromatolite. This one comes from Western Australia and is about 2.7 billion years old. And if you look in close, you see this rock is made up of layers. And what we've learned is that those layers are from ancient microbial mats, some of the earliest life on Earth that formed these layers on what was then the seafloor, microbes, single-celled organisms, using the energy of sunlight, using different kinds of nutrients flowing in the seawater, and organizing themselves into these layers. I'm at your mom's house asks, what is taking NASA so long to find them aliens? What active missions are they doing? Well, it's a big universe out there, but we're working on it. Obviously, we have rovers on Mars searching for the signs of ancient life. So we have a mission now on its way to Europa, a moon of Jupiter that is home to a vast ocean of liquid water. So we have a mission called Europa Clipper, orbiting the Jupiter system and making close passes by Europa in the early 2030s, helping us to understand if that ocean is habitable. What's the temperature, the pressure, what are the flows of nutrients and so forth? Is that ocean a place that could support life? And if it is, that would motivate us to send missions in the future that would land on the surface and maybe even tunnel under the ice in submarines to look directly for life on Europa. We also have a mission called Dragonfly that's going to launch in a few years and go to Titan. Titan is a moon of Saturn. It has a thick nitrogen atmosphere like Earth's, and it's loaded with organic molecules, the same kinds of molecules that led to the origin of life on Earth. Dragonfly is going to be basically a nuclear-powered drone that lands on Titan and samples the surface, examines those organic molecules to see if they're the kinds of molecules that may have led to life on Earth. And then it's going to take off and fly to different locations and repeat its experiments. So it's going to be the first time we've actually been able to explore a planet with an aerial craft that lands multiple places and does these kinds of experiments. We had a mission recently that went to an asteroid called Bennu. It collected over 100 grams of material from the surface of Bennu and brought it back to Earth. So we have in our labs now pieces of asteroid dirt. And what we found is that Bennu is full of the stuff of life. Amino acids. Amino acids are the things, the building blocks that make up proteins, and nucleotides, which are the components that make up DNA and RNA. So that's really exciting. It suggests that not just Earth, but all the planets were being sprinkled with the stuff that basically leads to an origin of life. So again, we haven't found life elsewhere, but we've been finding results that suggest that life should be common. @x/text asks, who came up with the flying saucer design and why did it stick? It turns out that flying saucers go back to a pilot named Ken Arnold, who was flying in the Pacific Northwest in 1947, and he reported something weird that he saw. What's interesting is that he never even said it was saucer-shaped. He didn't understand, and he described its motion as skipping like a saucer. I think it's like when you skip rocks or something and it kind of bounces like that. That's what he apparently meant. And then it got reported in a newspaper as pilot sees mysterious flying saucer, and thus a huge trope was born. Pugbug2 from Reddit asks, how did the first life form on Earth emerge? We know something about the most primitive life forms on Earth because we study modern organisms and how they're all related. There's something called LUCA, the last universal common ancestor. Even though we don't have an example of it, by seeing how different life forms have evolved from it, we can reconstruct the properties of that last universal common ancestor. And so we know that it liked hot conditions. We know that it was a single-celled organism. We have inferred that it occurred in a watery location. Some people think seafloor vents. Some people think tidal areas, little ponds that were being wet and dried or freezed and thawed would have led to the right kinds of chemistry. We also have experiments that show that the building blocks of life are very easy to create. If you mix gases that were in the primitive atmosphere and you spark them with energy sources that were likely present, lightning, ultraviolet light from the sun, you easily create these molecules like amino acids and other chemicals that clearly were important for the origin of life. You had gradual increases in chemical complexity. You probably had the formation of very simple membranes, which separate inside from outside and allow the creation of cells. There are certain chemicals which you put them in water and they create membranes. We call them vesicles. We know the necessary chemistry. We know what some of the earliest life was like. We sort of were closing in on it from multiple directions. Next question, Wind Dancer lore. WTF happened to Ceres? Ceres is a dwarf planet. It's basically one of the largest objects in the asteroid belt, but we call it a dwarf planet because it's large enough to be rounded by gravity. And recently, we sent a spacecraft there and we found some surprising things. Most surprising, you see this large crater in the center of this image. It's bright and white. And what we found is that's a salt deposit. And that salt deposit indicates that there was water, and it suggests that this was a water world at one point and may still even have liquid water on the inside. This is very exciting to astrobiologists because it means that dwarf planets like Ceres are places where you could have, in the past, had habitable conditions on the inside, and who knows, maybe at present some of these dwarf planets still have habitable oceans. So the more we explore the solar system, the more we're surprised by the level of activity on some of these worlds that we thought were dead. New Language 4727 asks, are there good scientific explanations for UFO sightings, such as the USS Nimitz encounters in 2004? There are some intriguing reports, and the USS Nimitz one is rather strange. You know, the ocean boiling, some object that didn't look like a human-made object seeming to fly at great speeds and so forth. I don't know how to explain it, but the bottom line is we see no reason to think this has anything to do with astrobiology or any kind of extraterrestrial technology. One of the videos that was recently popularized was taken by pilots. If you look at that video, it does look like something's moving sort of unnaturally fast, but it turns out if you analyze information we do have, a lot of that can be explained by parallax. That is, the motion of the camera can make something look like it's moving much faster than it is. So people that have actually looked at the data have said, you know what, the speed isn't as great and the motion isn't as unnatural as we thought. But you know, I'm the first to admit that there are things in our atmosphere that we don't understand. But as of now, I've not seen anything that tells me, aha, this is an extraterrestrial mystery. It's more like this is a plausible terrestrial mystery, but we don't know very much about it and we don't have very good documentation. Ashkir asks, what is the closest another habitable planet could be near Earth? It's probably roughly 4 light years. That is Proxima Centauri, which is in the nearest star system to Earth, which again, for perspective, the galaxy is about 100,000 light years. So 4 light years on the scale of the galaxy is very close. Of all the spacecraft we've launched, there are 5 of them that are on trajectories where they will actually escape our solar system. And most famously, Voyager 1 and Voyager 2 are on their way out. And they will maybe encounter another star system in something like 100,000 years. But of course, it would be millions of years before one of them actually sort of wandered into the vicinity of a nearby star. Fella on a Mission asks, why is water essential for life on other planets? Everywhere on Earth where there's life, there's water. And almost everywhere on Earth where there's water, there's life. Water is sort of the universal solvent that allows life to happen. Basically, we are organic molecules dissolved in water, dancing together and doing complex things and reproducing themselves. As far as we can tell, that's what life is. You clearly need a liquid medium because the molecules have to come together in this complex 3D dance that if they're just frozen in a solid or loose in a gas, they won't do it. So as far as we can tell, you need a liquid for life. Water is a common liquid in the universe and has those properties of interacting with organics that we have not been able to mimic with any other chemical in a lab. So we don't know for sure that the universe couldn't have done it in some other way. Maybe we'll be surprised and find life in ammonia or methane or some other liquid. But as far as we can tell, water is the key to life in the universe. So Gabe3115 asks, what do we think about assembly theory? So assembly theory attempts to describe the nature of life. What is the difference between living matter and non-living matter? How could we recognize that? Well, most of the universe is made of very simple molecules, like this carbon dioxide. That's not a very complex molecule, but if you look at the molecules of life, like amino acids, you can see carbon, 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 carbon bonded together in complex ways with other hydrogens, and they get much more complex than this, and they can be hundreds or thousands or tens of thousands of atoms bonded together. But you can see that this is very different from these simple molecules. And what assembly theory does is characterize the complexity of molecules in a way that tells us when something is complex enough so that it must have been made by life. One Skippy Dino asks, can someone give me a short explanation of the Drake equation and the probability of us being alone? I happen to have a copy right here. It's a way of thinking through the probability of extraterrestrial life that was devised by astronomer Frank Drake in the early 1960s. Frank Drake was the first one to actually point a radio telescope elsewhere from Earth and start to listen to see if he can find alien signals. And to help think through the probability of finding those signals, he came up with this really pretty simple equation. N is the number of communicating civilizations out there. R, that's just the rate of star formation in the galaxy. F sub P, the probability of planet formation around those stars. N sub E, the number of habitable planets per star. F sub L, the fraction of planets that have an origin of life. F sub I is getting into more speculative territory. That's the fraction of planets with life where intelligent life evolves. And of course, we only have one example, it's Earth. And then F sub C is even more speculative. That's the fraction of planets with intelligent life that have communicating civilizations that are sending or possibly receiving messages. Finally multiplied by L, or the average longevity of communicating civilizations. If communicating civilizations don't last long, perhaps because they do themselves in through nuclear war or climate change or some other process, then the numbers suggest that civilizations that we could communicate with are probably very rare and might be hard to find out there. On the other hand, if L is long, because some civilizations can last a very long time, they solve their problems, they learn how to live sustainably on a planet, then the math works out that there should be lots of civilizations out there that we can find. So the numbers vary widely depending on how you estimate some of these unknown factors. But some of these factors we do now know pretty well. We know the star formation rate in the galaxy, and importantly, we've recently discovered that planets are very, very common. That tells us that as long as the origin of life is not super, super rare, there must be lots and lots of planets out there with life. Chad from the future asks, why doesn't the Europa Clipper deploy something into the moon to check for life? At one point, there was the idea of including a lander on Europa Clipper, but it was decided that the real point of this mission is just to characterize Europa and decide if it is habitable. We'll then know which locations on the surface are the right locations to send a lander, whereas now we would sort of be guessing. Also, it costs a lot to send a mission to Europa, and the more complex you make the mission with an orbiter and a lander and other pieces, the price goes up and then you're less likely to have the mission at all. So if Clipper does confirm, as we suspect, that Europa is a habitable world, you can be sure that in the future we will be sending landers to directly search for life there. Browner555 asks, what is Area 51 actually used for? Well, I could tell you, but then I'd have to kill you. No, just kidding. Area 51 is a place where experimental military aircraft are tested. This is common knowledge, and that's all I know, and I've seen no evidence that it's anything else. Rinse the Plates First asks, what is the Fermi paradox? So the Fermi paradox is named after the great Italian-American physicist Enrico Fermi, who famously asked, where is everybody? With all the possible life forms and civilizations in the galaxy, and with a galaxy that is billions of years old, why aren't there obvious signs of extraterrestrial life? That's really what we mean by the Fermi paradox. In my view, it's not really a paradox because we haven't really looked yet very thoroughly. With SETI, the search for extraterrestrial intelligence, Jill Tarter, who's one of our great SETI scientists, has likened it to if the universe is an ocean, we've basically searched a teacup full of water. Even though we've been searching with radio telescopes for 60 years now, if you look at the number of stars we've looked at carefully and the frequencies we've analyzed compared to the amount of search space there is, that it's just a teacup in the ocean. So we could have easily missed it. Infinity Scientist asks, what kind of technosignature could be detected from a very far away galaxy? Oh, that's an interesting one. If you were an alien looking at Earth, you might notice that our atmosphere has changed. You might notice lights from our civilization. Those kinds of things we call technosignatures. Just any observation that can betray the existence of some kind of technological activity or civilization. The only kind of technosignature I can think of from a very far away galaxy would be some kind of incredibly advanced civilization that is actually manipulating the geometry of that galaxy in some way, creating things like Dyson spheres, these large structures in a solar system that are meant to gather all the solar energy from that star and power their technology. And that would put out an unusual infrared signature. So we actually have the ability to look for things like that. When we're talking about the possible abilities of very advanced technologies, you almost have to get very out there. Like Arthur C. Clarke said, any sufficiently advanced technology may be indistinguishable from magic. And the fact is, if you look at how fast technology changes, it's very hard to say it would be impossible for some civilization to create these astro-engineering works that would be visible from distant galaxies. Ulterior Kid 324 asks, what is SETI? Is it just people listening to alien radio stations? So SETI stands for the Search for Extraterrestrial Intelligence. And it's been mostly radio searches, but more recently now we have what we call optical SETI, where the idea is that they may not be sending radio pulses, they may be sending laser pulses. So with optical SETI, we look in optical visible wavelengths for laser pulses from other stars. We also shouldn't confuse SETI with METI, which is Messages to Extraterrestrial Intelligence, which is more controversial. Some people are opposed to METI for a couple of reasons. One is they think it's arrogant to assume that any one person or program or institution could speak for all of Earth. User 0301 asks, NASA announced it has detected a gas on a planet 120 light years away that might indicate life. How? So one of the things we do is we look for what we call biosignature gases in their atmospheres. A report was published that a chemical called dimethyl sulfide had been detected in the atmosphere of an exoplanet called K2-18b that might have a habitable watery environment, which would be a very exciting thing to find. Dimethyl sulfide is a gas that on Earth is associated with life, largely, although there are other ways to make it. So they're not sure that dimethyl sulfide has really been found on this exoplanet. So as far as how we detect gases in a distant atmosphere of an exoplanet, we use spectroscopy. Basically, we observe the amount of light at a range of wavelengths across the visible, the infrared, the ultraviolet spectrum on an exoplanet, and we've learned that patterns in those spectra reveal the existence of different gases. So for instance, this is a spectrum from an exoplanet called WASP-96b. You can see some of these peaks and valleys. This is a peak that indicates water, which is pretty amazing because water is one of the key gases for thinking about life in the universe. Here's a question from the Ask Historians subreddit. Are there any compelling cases of UFO/UAP sightings in history? From an astrobiology perspective, the short answer is no. There are a lot of phenomena in our atmosphere that have not been characterized yet. There have been things discovered recently, strange high-altitude lightning formations called sprites that were reported and dismissed, and then they turn out to be real. I would not doubt that there are strange things in our atmosphere that have not yet been identified. Whether they are any indication of alien technology, to me, that's a kind of last resort explanation. Even if they are technology, I would probably say it's much more likely that they are human technology that some humans know about and other humans don't. Why we have to resort to aliens to explain this, to me, if anything, that seems kind of a lack of imagination or really a big leap that I wouldn't be prepared to make without some more specific evidence for that. @RedactedMedia asks, what if we could see and interact with the shadow biome? What if there's some other form of life on Earth that we're not even fully aware of? What if there's another form of life, perhaps hiding underground or in some place that we think is very uninhabitable because our kind of life couldn't exist there, highly acidic places or places that are so extreme that we think life couldn't exist, that in fact does exist on Earth. And that's the notion of a shadow biosphere. And by its very nature, the concept implies something we haven't really encountered or thought of yet. It's the kind of question that's worth our keeping in mind as astrobiologists so that we don't assume that we know everything about life when in fact we're just beginning to understand the possibilities for life in the universe. Here's another good question. Was there ever life on Mars? What I can tell you is the more we've studied Mars, the more we've learned about its earliest environment. It seems to be similar to the early environment of Earth at the time when the origin of life is believed to have happened. There are dried up river valleys, there are dried up lakes with waterborne sediments, there are flood valleys, all kinds of signs that Mars, when it was young, was a wet and warmer place with a more clement climate, with lakes, with flowing water, and most likely with organic molecules. So Mars, we believe, had the conditions for an origin of life. Have we found evidence for early life on Mars yet? No, but we're searching for it. And that's one of the reasons we have these Mars rovers, and hopefully someday bringing samples back so that we can examine those rocks in our laboratories on Earth and identify for sure whether there was life on Mars. Python11 asks, would a Venus sample return mission be possible? It wouldn't be that easy because Venus has a very thick atmosphere. You can't see the surface because it's surrounded by these thick clouds of sulfuric acid, so battery acid. So it's not an easy place to explore or to get to. Ultimately, we would really like to do so. Having samples on Earth is so valuable because instead of having to send your little instruments up there and do the experiments and radio home the results, you can have a whole Earth laboratory. You can have all the time that you want using all the resources of our laboratory. Poquoro asks, is a habitable planet with no tectonic activity plausible? We're still trying to understand the nature of habitability, but one thing that's certainly true about Earth, the one habitable planet we know, is that possibility for life here is facilitated by plate tectonics, by the motion of the Earth's surface driven by the motion of the interior, which moves the surface around and not only makes mountains and earthquakes and all that, but brings nutrients continually to the surface and sort of renews the surface of the Earth, keeps it fertile. We definitely think tectonic activity is related to habitability, and you would imagine for a planet to be habitable, there needs to be some kind of ongoing geological activity. Is it absolutely required? We don't know. For instance, there are these ocean worlds like Europa and other places where habitability could just be on the inside, and maybe you would not have tectonic activity in the outside if there were other energy sources and way of recycling nutrients. Coochieman127 asks, do you think we detect intelligent life within the next 100 years? So with the James Webb Space Telescope, we're just getting to the point where we can identify gases in exoplanet atmospheres. And with future space telescopes, then we will have the ability to really say what's in that atmosphere of this exoplanet and that exoplanet. And once we can do that, then we at least have a chance of finding some kind of technosignature. Similarly, our radio searches are getting much more sophisticated. So the completeness with which we're examining the rest of the universe is increasing rapidly, which makes me think, again, if the aliens are there waiting to be found, that within the next 100 years, we have a pretty decent chance of finding them. So those are all the questions for today, and thanks for watching Alien Support.